Alright, hi everyone. So today is a new question. So let's dive into it. Okay, so this is the question for today. The question is to ask what is the sum, all right, from x is equals to 1 to infinity of x squared over 2 to the power of x. Okay, so how are we going to find this how do we solve it? Okay, this question. Now, very quickly, for me, I establish the equation first. However, in our earlier question, we are actually trying to find what is the x squared over 2 to the power of x. All right, but before we actually try this, I first establish another series. This series is to find, okay, for x over 2 to the power of x to infinity. What is this sum equals to? Thus, I just write out all these terms. Okay, gives us half 2 out of 4, 3 out of 8, 4 out of 16, etc. to infinity. All right, and we can see from here, okay, we can just factor out half, okay, and within that bracket, we have 1, 2 over 2, 3 out of 4, 4 out of 8, 5 out of 16, etc. All right. And the next step, very quickly, we can just take out half. All right, and for 1, I will just put it here. 1 is 1, half is half. All right, and from this term onwards, from 2 out of 2 onwards, I can express this as the sum from x is 1 to infinity of x plus 1 over 2 to the power of x. All right, I hope you can see what I'm trying to establish here. These are the entire sum that I established out. Now, at this point, okay, I can write out the equation. On the left-hand side is what we are trying to find. On the right-hand side, we have half. If I expand this back in, I have half multiplied by 1 is give us half plus half, okay, of, if I'm going to separate out this fraction, I have x over 2 to the power of x and 1 over 2 to the power of x. Thus, inside these are where the half got, is over here, okay, because I expand it in. Thus, over here I have, okay, the sum from x equals to 1 to infinity of x over 2 to the power of x plus half the sum from x1 to infinity of 1 over 2 to the power of x. Okay. So now I simplify the equation. Okay, so on the left, what's going to happen is because I'm going to bring this term from the right over, thus I have to subtract, okay, half of the sum from x1 to infinity of x over 2 to the power of x. So if I'm going to bring this over, okay, this term, if I'm going to bring this over, I will subtract, okay, on both sides, and thus on the left hand side I have half the sum of x equals to 1 to infinity of x over 2 to the power of x. So over here I have, what do I have on the right? I have half, which is half, this remains, and over here I have half the sum of x equals to 1 to infinity of 1 over 2 to the power of x on the right hand side. So if you look at this term, okay, the sum from x1 to infinity of 1 over 2 to the power of x, this reminds me of a geometric series, okay, an infinite geometric series. So by applying, okay, the equation or the formula to the infinite geometric series for the ratio that's lesser than 1, okay, we have the first term over 1 minus the ratio. So the first term in this case will be half, because when x is 1, the first term it gives us half. And 1 minus the ratio for every term, okay, the ratio is also half. So basically half over half, okay, because 1 minus half is half, half over half is 1. So this entire, okay, sum over here, okay, will be equate to 1. Okay, it will converge to 1. Thus, on the left-hand side, this is what I have, is equals to half plus half multiplied by 1. Okay, I hope you see what I mean. Okay, and thus half plus half, which is equals to 1. All right. So now I have, okay, the sum from x1 to infinity of x over 2 to the power of x, which is equals now to 2 times 1. Okay, because why? Because I'm going to multiply 2 on both sides to get rid of the half on the left. Thus, I have 2. So thus, that is the answer for this entire series to converge. Okay, so the sum, okay, of x is 1 to infinity of x over 2 to the power of x converge at 2. All right, so this is the convergence for this infinite series. Okay, so what has this got to do with what we have established earlier? Remember earlier we are asked to find what is the sum of x to the power of 2 or x squared over 2 to the power of x from x1 to infinity. So okay, now let's tackle that. Okay, but keep in mind what I've derived earlier. Okay, keep in mind, okay, this convergence, okay, this result for this convergence series. Okay, so now we are going to tackle what is x to the power 2, x squared over 2 to the power of x for this x1 to infinity. Which same thing, we are applying the same technique that we've applied earlier. We establish all these terms. So if we're going to write out the terms, we have half, 4 out of 4, 9 out of 8, 16 out of 16, 25 out of 32, 36 out of 40, 64, and so on to infinity. And if you notice, same thing, we are going to take out half, okay, as our factor. Notice there's a half as a factor for every term. Okay, so half, there's another half, etc. So if we are going to take out the half as what we did earlier, okay, we actually take out half as the factor. Thus, over here in the bracket, we have 1 plus 4 out of 2, 9 out of 4, 16 out of 8, 25 out of 16, 36 out of 32, etc. to infinity. So over here now we have, okay, if you look at this pattern, we have 1 is 1. 4 out of 2, for instance, we have 2 to the power 2 or 2 square over 2. Okay, and 9 out of 4, I can have 3 square out of 2 to the power of 2 or 2 square. 4 square, 2 cube, 5 square, 2 to the power of 4, 6 square, 2 to the power of 5. Notice? Okay, so the numerator, we notice a pattern. Okay, it starts, okay, if you are going to start from 2, okay, and the power is a constant, which in this case is square, okay, or 2. For the denominator, you can see that it increase, okay, from 1, 2, 3, 4, 5, accordingly to the terms. So how are we going to write this, okay, in sigma notation? The next step, okay, half is half, 1 is 1. Okay, so everything in this bracket over here, from 2 square over 2 onwards, I can establish as this, okay, infinite series. Okay, I can just write it as x, the sum from x equals to 1 to infinity of x plus 1 square, okay, over 2 to the power of x. How do I know? Because as I know that you can see that these terms, okay, for the power in the denominator, it goes according to terms. So if the term is going by x, I'm just going to put it in terms of x. And okay, for the numerator, you can see that, okay, it starts from 2. So if the first term, it starts from term equals to 1, okay, you have to add 1 to it, okay, to every term. So when term is 2, okay, it will be 3. Term equals to 3 plus 1, which is 4. Okay, term 4, 4 plus 1 is 5, etc., etc. Okay, I hope you see what I mean here. Okay, so the next step, okay, I just write out what is on the left-hand side. Okay, the sigma notation from x1 to infinity of x squared over 2 to the power of x. So I'm going to write this entire chunk out, okay, from the right-hand side. So the right-hand side, notice if I'm going to expand in half, okay, if I'm going to expand half in, I have half times 1 is half times the entire sigma notation over here. So this entire sigma notation, it can be broken up into 3 parts. How do I do that? Because we all know that x plus 1 square is x squared plus 2x plus 1. Okay, you can just expand it out, and that's what we get. So these are the respective terms that we have. Okay, x squared, x, and 1. Okay, I hope you see what I mean, the numerator. Okay, those are in the numerator. If I expand out, you will get these 3 terms. Thus, denominator remain as 2 to the power of x. And I can split this entire sum into 3 parts, okay, into 3 different sums. All right, and you can see they are over here. Okay, so this is just a broken down from what we see earlier. All right, and half remain as half. Okay. So the next step, you can see that what's going to happen? Now notice if I'm going to further expand half into every terms, okay, into these three terms, I will get, okay, half, okay, to the sigma, okay, or the sum from x1 to infinity of x squared over 2 to the power of x. Now if half multiply by 2, okay, of the sum from x1 to infinity of x over 2 to the power of x, notice it becomes only 1 now. And if I'm going to multiply half into this of x1 to infinity of 1 over 2 to the power of x, okay, I will have half, okay, over here. So I hope you see what I mean. This is just I multiply in, and I get here. So here, the 2 will be gone. Okay, I hope you see what I mean, because to the 2x, in terms of 2x, I can bring out the constant 2. All right, because it's x squared plus 2x plus 1, remember? So I can take out the 2 because since 2 is a constant, I can take it out. X I cannot because it is a variable. So the variable remain inside. All right. And now what's going to happen? Now notice that this term, just like what we saw earlier, like how I derive x over 2 to the power of x, the sum. Now I just going to bring this, okay, I'm going to subtract half of the sum of x1 to infinity of x squared over 2x to the power of x. All right, on both sides. Now if I'm going to subtract on both sides, notice here is 1. So I minus half, I get half of the sum of x equals to 1 to infinity of x squared over 2 to the power of x. Notice I just rearrange the equation, in other words. And thus I have half, because half is half. All right, and over here I left with, okay, only these two terms. So now it's very straightforward and it's very clear now. Okay, what do I have? Okay, remember earlier, just now we have derived, okay, what is the sum from x1 to infinity of x over 2 to the power of x. Remember, just now we noticed that it converged at 2. So we can substitute that in. And likewise, okay, for 1 over 2 to the power of x, the sum, okay, from x1 to infinity, okay, remember, it is a geometric series, an infinite geometric series. So since if that's the case, okay, and we know that, okay, it converged at 1 from what we saw earlier, remember? Okay, so from there, I can deduce that, okay, half of the sum of x from 1 to infinity of x squared over 2 to the power of x is equals to half, okay, plus, okay, over here, this is, yeah, as you can see over here, remember this entire thing is 1. So half times 1 is half. So this is half. And this, okay, can be equals to 2. Okay, I hope you see what I mean. Okay, so this one later on, okay, in the next slide, I will transform this as 2. I'll write this down straight away as 2. Okay. So now, okay, on the left-hand side, it will be half the sum from x1 to infinity of x squared over 2 to the power of x, and that's our objective that we are finding, is equals to half, okay, plus, okay, the sum from x1 to infinity of x over 2 to the power of x plus half. Okay, remember, just now I say I'm now going to put this as 2, okay, from the earlier series, okay, since it's converging at 2. Okay, so I have 2 plus half, all right, over here. Okay, thus, the next step, okay, so I have 2 plus half, okay, equals to half of the sum from x equals to 1 to infinity of x squared over 2 to the power of x. Okay, on the right-hand side, if I evaluate this, I get 3, because half plus 2 plus half is 3. And likewise, I multiply 2 on both sides of the equation. Thus, that is what I got. Okay, so the answer to this question of the sum of x from 1 to infinity of x squared over 2 to the power of x is equals to 3 times 2, which is equals to 6. Okay, and that is our answer. All right, so that's all, okay, for today. And thank you for watching. Have a nice day. Good night. Bye.